In this next example, one of the strategies I can use is using a conjugate. So cos plus 1 is a conjugate. There's a conjugate that goes with cos plus 1, which is cos minus 1, or I'm going to use 1 minus cos. When I multiply those conjugates together, I get the Pythagorean identity for the, the sine and cos. So I get cos 1 minus cos squared, that would be equal to sine squared. So I notice that this sine squared and this cos squared, this cos plus 1 can match. So the first thing I'm going to do is I'm going to rewrite this with tan theta. I'm just going to switch it around to 1 plus cos theta. And I'm going to multiply the top and bottom of this. Again, I have to do top and bottom because I don't want to change the value of the right-hand side. So if I multiply the top and bottom by the same, I don't change the right-hand side fraction. And by doing this, what I'm going to do is in the denominator, I'm going to generate a Pythagorean identity, and that should match the sine squared on the left-hand side. And when I multiply this through, I end up with tan theta minus cos theta times tan theta. I'm going to convert that tan theta into sine over cos, because I can then see that the coses will cancel out. So I'm just going to highlight that. That comes from there. Okay. In the denominator here, I'm going to end up with 1 minus cos squared theta. And that's what I wanted, because now what I've done is I've made the denominator here match the denominator here. And if I make the denominator match, usually everything else falls into place. So in the numerator over here, I get tan theta minus the cosines cancel out. I end up with sine theta. In the denominator, the 1 minus cos squared, I'm going to use a Pythagorean identity and convert that to sine squared. Okay, so that's my Pythagorean identity. I now have the left side equals the right side. I've proven that identity. Again, it's important to note that there are many, many different ways to do this. I could have done this entirely on the left-hand side. In this case, I did it entirely on the right-hand side. I could use different identities. There's infinite ways to do this. As long as you don't make up some identities that don't actually exist, it will eventually work out. So here I have sine alpha and cos beta. So I want to find the sine of alpha plus beta. Well, whenever I see a plus in there, I need to make sure I go to my identity sheet. And my identity, I need to apply an identity here. So sine of alpha plus beta, the identity is sine alpha cos beta plus sine beta cos alpha. Okay, that's from just my formula sheet. Now to apply this on the right-hand side, I have to get sine alpha cos beta. Well, I have sine alpha cos beta given to me already, so I'm just going to fill that in. So 3 over 4, that's my sine alpha. That was given to me at the beginning. And I also have cos beta given to me, which is 1 over 5. There's my cos beta. But what I don't have is sine beta and cos alpha. But I can get those because I have been given sine alpha. So if I've been given sine alpha, I can draw a picture for alpha. Okay, and sine alpha, we really should actually qualify. Let's just say, make sure that this is in quadrant 1 and quadrant 1. Okay, because if we don't specify it's in quadrant 1, we actually can't draw alpha and beta. So sine alpha is in quadrant 1. So sine alpha is going to look like this. 3, 4, and then using Pythagoras, I'm going to get 16 minus 9, or root 7. So there's my picture for the angle alpha. That means then I now have my cosine of alpha. I'm going to do the same for beta. I want a picture for beta. Beta's in quadrant 1, so it's going to look like this. 5, 1, and then square root 24 when I use Pythagoras. And so beta is going to look like this. I want sine beta. So sine beta, I'm just going to get a different color here. Sine is to do with the vertical, so I have sine beta. So now what I can do is I can just replace all this with numbers and work out the actual value of sine alpha plus beta. So this works out to be 3 over 20 plus sine beta is going to be root 24 over 5. Okay, it comes from over here, and then cos alpha, take a look at the alpha diagram, it's root 7 over 4. So that's going to be my cos alpha, and then I can just simplify this expression. So 3 over 20 plus square root 7 times 24. 7 times 24, I'm just going to use my calculator for this. I end up with 168. So square root 168 over 20. This will, because of the nature of this formula, we're going to get a common denominator. So I'm going to rewrite this as 3 plus square root 168 over 20. It might be a good idea to just rewrite that with the perfect square involved. So the perfect square that divides into there is going to be, looks like it's going to be just the 4. So this is good enough. I probably should rewrite this as 2 root 42 over 20. So there is using the the sum identity for sine, using the original statements to determine the other ratios involved in that formula.